Okay, in this video I'll show you how to derive the formula for the sum of a geometric series. And what I'll do is I'll put two side by side. As you can see, I've got one with numbers in, which is the series 3 plus 12 plus 48 plus 192. Yes, I know we can add it with a calculator, but I'm going to show you a step-by-step process which links directly to the general form which uses algebra. And that's the one that's going to be on the right hand side in a minute. Okay. So let's have a look at what we're doing. We have to find the sum of, which is Sn, of 3 plus 12 plus 48 plus 192. Alright. Now what I'm going to do with this is, if you look at it, how do I get from one term to the next? What do I do to 3 to get 12? What do I do to 12 to get 48? Correct. The common ratio is 4. Alright, each term is 4 times bigger than the last. So what I'm going to do is I'm going to multiply both sides by 4, in other words, everything by 4. So my total will now be 4 times bigger, so that will be 4 lots of my total equals, right, what are you watching? 4 3s are 12. 4 12s are 48. 4 48s are 192. And 4 lots of 192 is 7, 6, 8. Alright. Now I've just written them down after multiplying by 4. Now watch what I do. I'm going to write the original version, which is 1 lot of my total, and I'm going to write that underneath. But look how I do it. Okay, think about this. Tell me what you notice. What are you thinking now? By doing it this way, what do you see? Alright, so because I've got pairs of numbers that are the same, one way of eliminating those is to subtract. So if I do 4 lots of my total take away 1 lot of my total, then I get 4 lots of my total take away 1 lot of my total. Well, that's 3 lots of whatever my total is. Okay. Now, coming back up here, there's nothing here above the 3. So 0 take away 3 is negative 3. And then watch what happens. 12 take away 12, 0. 48 take away 48, 0. 192 take away 192, 0. 768 take away, oh, well, there's nothing there. So it'd be just 768. So we have negative 3 plus 768 is 768 take away 3, 765. But this is 3 times too big, so I'm going to divide both sides by 3, which will give me an answer of the total, one lot of that total is 255. Now you can check that on your calculator, which you could have done it in the first place, I know. But as I said, the idea is to look at the step-by-steps and see how clever it is. All right. Now, the first mathematician to do this must have been quite cleverly thinking here. It's not something that's obvious. And what we're going to do is do exactly the same steps with our algebraic version. Now, this you've seen before. This is our sequence, which we've derived before, and all we're doing is saying, look, let's add those terms together, let's add them all together all the way through there, okay, add them all up, and that gives us our series. Okay, now what is the common ratio? What do I do to each term to get to the next? Yep, I multiply by r. So what I'm going to do this time, I'm going to do r times everything. Just like I did before, I did 4 times everything. This time I'm going to do r times everything. Now at this point here, you don't have to memorize this, you don't have to know how to derive this. This is just for interest only. So if you want to finish and do something else, go get a cup of tea or something, that's fine, because this is not for everybody. Alright, now if I times the left side by r, I must times everything else by r. So I've got u1 r plus So that's u1 times r. Then I've got u1r times r. Well, I've got r times r there. So it's u1 r squared. Plus, I would have a u1 r cubed. I'd have a u1 r to the power of 4. Eventually I'd have a u1 r to the n minus 1. And then finally I'm going to multiply this last term by n, which is u1 r to the n. Every power's gone up by 1. Let me rewrite the original underneath, and you'll see it match up again quite nicely, except for the fact that it stops right there. Okay. Now do the subtraction again. R lots of Sn take away 1 lot of Sn. Well, that would be r minus 1 lots of Sn, our total. So if I did 10 Sn's take away 1 Sn, I get 10 take away 1 is 9. If I do 5 Sn's take away 1 Sn, I get 5 take away 1 is 4. Here I've got r of them, take away 1 of them. So I've got r take away 1, lots of my total. Going back up again, right hand side now. There's no term with u1 just on its own, so it's 0 in there. Okay, and I'll put a 0 over here just to fill in the columns for you. So I've got 0 take away u1. Then u1r take away u1r, they're identical, so that must be 0. u1r squared take away u1r squared, they're identical, so that must be 0. u1rn, blah, 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 keep going, keep going, keep going, until you get to this point here. They're identical, so you end up with 0. The final term is u1rn take away 0, which is u1rn, r to the power of n. Okay, so I've got this r minus 1 lots of my total equals, you fiddle it round, just writing it around the other way, and it ends up like that. Excuse me. So I've still got r minus 1 lots of my total. Now here you can see that there's a u1 in both terms. So u1 times r to the power of n is u1rn, and u1 times 1 is u1, and I'm separating that with a subtraction. If this left hand side was 5 Sn, I'd divide by 5. If it's 12 Sn, I divide by 12. If it's r minus 1, what do I divide by? R minus 1. But if I divide the left side by r minus 1, I must divide the right side by r minus 1. That gives you that the total of all the terms of a geometric series, beg your pardon, is u1 r to the n minus 1 all over r minus 1. Done.